So now that we're using Excel, or you're using Excel, you should have collected all of your data by now and logged it somewhere. That's what we've done here. These centripetal accelerations were calculated by taking the square of our x acceleration plus the square of our y acceleration, taking the square root of it, and that's equal to our centripetal acceleration. It's the vector sum of those two. This omega here was the mean value that we read off of our data. Each one of these rows represents one toss of the IO lab device. So there's 4 tosses here at different speeds, and now we're going to use this data to compare it to our formula for centripetal acceleration. Here you see I've squared the omega that we found, and that our centripetal accelerations are the same. So these are going to be 2 different plots. So the first plot we're going to look at here is where we're plotting omega versus centripetal acceleration. Notice that my x variable is the first column and my y variable is the second column. That is very important so that we have our x and y axes on our graphs appropriate. So we're going to highlight the data we're looking to graph. Then we're going to go to Insert. We're going to click this chart, which is the scatter plot. And we're going to click the first one that doesn't have any lines associated with it. We just want the points themselves. Now we're going to select one of the points, which is the same as selecting the data. And then we're going to right click and we're going to go to Add Trendline, and we're going to choose a power series because we want to fit it to a power series. And then we're going to scroll down so we can include the equation on the chart because that's what we're going to use for analysis. So now that we have our plot with our trend line and our power fitting, we're going to use the coefficient of our leading variable as well as our power to compare this equation to our equation for the comparison between centripetal acceleration and omega. We should compare our leading coefficient to the radius that we're looking for, or distance between our A and G on the IO lab. So that's one of the plots we're going to make. The second plot we're going to make is we're going to use our omega squared AC data, our centripetal acceleration data. We're going to highlight that data again. Once again, we're going to go to Insert, and we're going to go to Scatter Plots, pick the same type of scatter plot. We're going to once again select our data. We're going to add trend line, but this time we're going to use a linear fit. And once again, we're going to add our equation. And this equation, again, is going to be used for our analysis. We should see that our leading coefficient should also be similar to our radial distance between G and A when it was spinning. As you can see on our data, since it's fake data, it is perfect. So these are the numbers you're going to be comparing to your measured value for R in your analysis portion of your lab.